Hello everyone, this is Ashwati Krishnan. I'm back again with another interesting topic in physics. So today we are going to start module 5. So before you start watching this module, please make sure that you have learned and you are thorough with module 1 to 4, which will help you understand this module better. So let's continue. So be ready with your pen and a book to note down the important points. So today's topic is rules for obtaining images formed by spherical mirrors. So we have learned about spherical mirrors in our previous lesson. We have learned about concave and convex mirrors. So in this module, we are going to see rules that needs to be followed while drawing ray diagrams. So let's move on. So I want you to draw a concave mirror, convex mirror. So principal axis, pole, focus and center of curvature. These are the important points that you should label while drawing the ray diagram. And one more point you should keep in mind here is when you are labeling the points. Okay, so we have learned a relation between radius of curvature and focal length, that is r equal to 2 times focal length. So when you are labeling the points, so you have to take an equal measurements between P and F and C. Okay, for example, suppose this is 2 centimeter, this should be 2 centimeter, because to satisfy this relation, r means from here to here is your r. Okay, so if this is 4 centimeter, so your focal length should be half of that. That is why I told you to draw the points with equal measurements on the principal axis. Okay, that is the important point you should keep in mind. Okay, I hope you have drawn the mirrors, labeled the important points on the principal axis. So let's begin with rule 1. Yes. So what does the rule says? So the rule says a ray parallel to the principal axis after reflection will pass through the principal focus in case of a concave mirror or appear to diverge from a convex mirror. So here I have merged both concave and convex together. This rule is applicable to both. So first one says will pass through principal focus. So passing through principal focus is in case of concave mirror, and appear to diverge from the principal focus is from convex mirror. So I want you to try the ray diagram before I explain. So using this rule, just give it a try. Now let's see how we are going to draw the ray. Okay, what is the first sentence? A ray parallel to principal axis. So you have to draw a ray parallel to principal axis. So a ray means it is very important that you are labeling the arrow. Arrow shows the direction of light. So what happens to the ray? It will pass through principal focus after reflection. So after reflecting from the mirror, this is the mirror. From the mirror, it reflects and passes through principal focus. See, arrow shows it is passing through principal focus. This is rule 1 of concave mirror. Now let's see how it is applicable to convex. So what does it say? Again, a ray should be parallel to principal axis. What happens? After reflection, it reflects, the light ray reflects, and what happens after reflection? It appeared to reflect from focus. See, this direction shows that the light ray, the reflected ray shows that it is coming from the focus. So why I have used dotted lines here? Because it is virtual, it is imaginary, it just appeared to diverge. So this dotted line indicates it appear to diverge, and from here it reflects. This is rule 1. I hope rule 1 is clear to you. So don't forget to draw the rules in your notebook. This is very, very important to draw ray diagrams. Now let's move on to rule 2. So here is rule 2. Again, I want you to draw both the mirrors, principal axis, and label all the important points. So while labeling the points, don't forget the distance between the points. Okay, they must be equal. P and F and C. The measurements must be equal. Then what does rule 2 says? A ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. Again, this is applicable to concave as well as convex mirror. What does it says? Yeah, let's see how it works in concave. Yes, a ray passing through the principal focus. So it is passing through the principal focus. It hits the mirror. Then what happens? Very good. It emerges parallel to the principal axis. So just opposite of rule 1. What is rule 1? Yeah, if a ray is parallel to principal axis, after reflection it passes through principal focus. But here, a ray which is passing through principal focus, it hits the mirror, and after reflection it becomes parallel. So just opposite. Now for convex. Now let's see for convex. See how it works. Yes, a ray which is directed towards, see the arrow shows it is going to focus. So a ray which is directed towards focus, then what happens to the ray? After reflection, it becomes parallel. This is the parallel to principal axis. This is your principal axis. So it becomes parallel to the principal axis. So easy, right? This is rule 2. Now let's move on to rule 3. Again, I want you to draw both the mirrors, concave mirrors and convex mirror, and label all the points on both the diagrams. Now let's see what rule 3 says. A ray passing through the center of curvature of a concave mirror or directed in the direction of center of curvature of a convex mirror. So this is convex, this is concave. If it is passing through center of curvature, what happens? After reflection is reflected back along the same path. Wow, that is quite interesting. When it passes through the center of curvature, it hits the mirror. Then what happens? The arrow shows it is hitting the mirror. Then after reflection, it goes back along the same path. The same is applicable for convex. Let's see how it works for convex mirror. See, it is directed towards the center of curvature. See, arrow shows the ray is directed towards the center of curvature. Then after reflection, it reflects back along the same path. Now my question here is, why the ray of light is reflecting back along the same path? What could be the reason here? When it is passing through center of curvature, it is just passing, going back along the same path. What could be the reason? I can give you a clue. When we discuss about the plane mirror, okay, in plane mirror we know that there is a normal. When light ray passes through this normal, what happens to the light ray? It reflects back along the same path. Why? Because here angle of incidence is 0. So according to laws of reflection, the first law of reflection, angle R must be 0. So to satisfy this, the ray will reflect back along the same path. So wherever you see that ray is reflecting back along the same path, what does it mean? It means that it is passing through normal, or it hits the mirror perpendicularly. So what does this mean? So any ray which is passing through the center of curvature reflects back along the same path because it hits the mirror at its normal. It hits the mirror at its normal. So remember this point. This is very, very important point. That is the reason why it reflects back. So if it passes through this point, see, let me change the color. If it passes through, see, like this, if the light ray is passing through this, what happens? Yeah, it will reflect back. Why? Because that is also passing through C. So any ray which is passing through C, it will reflect back along the same path because it hits the mirror perpendicularly. That is rule 3. Now the last rule, rule 4. So again we have to draw concave and convex mirror and label all the points. So rule 4 says a ray incident obliquely. What do you mean by obliquely? Obliquely means, yes, slanting, making some angle, okay, to the principal axis. So a ray which hits the mirror in a slanting manner, okay, towards the pole of the spherical mirror is reflected obliquely. So this is the meaning of obliquely. Obliquely means with some angle with the principal axis, slanting manner. Then what happens to the ray? Again it reflects making the same angle. Why it says that same angle? So we know that any line, see, this line is acting as the normal. So what is the angle between incident ray and normal? Angle of incidence. So what is the angle between reflected ray and normal? Angle of reflection. So in order to satisfy this angle I, this angle and this angle must be equal. That is rule 4 says if a ray hits the pole of the mirror obliquely, okay, it will reflect in such a way that angle of incidence must be equal to angle of reflection. The same is applicable for convex. See, here also it hits the pole. Then what happens after hitting the pole? Yes, it reflects in such a way that this angle and this angle are equal. Why? Because this is the normal. In the previous diagram also, okay, this we have discussed the normal. In our previous diagram, yeah, this one. Here also we can draw the normal. How we will draw normal here? Yes, it should pass through the center of curvature. So this angle and this angle must be equal. The same is applicable here also. It should pass through, sorry, I'm not able to draw. It should pass through the center of curvature. So center of curvature act as the normal. So angle of incidence and angle of reflection must be equal. Same thing is for rule 1. When you go back to rule 1, here also you can draw the normal. So when you draw the normal should pass through center of curvature, because center of curvature, any ray which is passing through center of curvature will act as the normal. So this angle and this angle of incidence, angle of reflection. Here also same. See, when we draw, this is how we draw. This is angle of incidence, this is angle of reflection. But to avoid confusion, we usually do not show the normal. Okay, we usually draw the symbol diagram, only incident ray and reflected ray. But we know that normal is a line which is passing through the center of curvature. So when you draw the ray diagram, it is not necessary that you should show the normal line. Okay, so that's it for today. So we have 4 rules. Be thorough with the rules. Don't try to by heart the rules. Draw and learn the rules for a better understanding. You should draw and practice all the rules thoroughly so that your ray diagrams will be easy. So that's it for today. So we will see with another interesting module in our next video. Thank you. Have a good day.